Hi everyone, welcome to another video lecture for Canese 6770. Today we're going to be talking about creating tidy data, and we're going to be going over the selected exercises from chapters 8, 9, and 10. So in the homework assignment, which is on Canvas, right, I've pulled out individual questions and rephrased some of them, but otherwise, ideally, you're working through the text and you're running the code as you go through the textbook, and it provides you with sort of the rationale for why we're interested in some of these data processing steps that we're going to be doing. But then as you get to the different questions and those exercise sections, right, you want to come back over to your actual lab assignment and then see which of those questions I've pulled out and in a few cases lightly rephrased, and then try to answer those questions. So our first exercises are from chapter 9, starting on page 151. And we want you to, in your own words, describe how the variables and observations are organized in each of the sample tables. So we want you to talk about, the extent to which these adhere to tidy data principles, and why you think they do or why you think they don't. There's no actual computation that is required here. I would just like you to look at the various tables that we are reading in from the Tidyverse package, and then evaluating those tables in terms of how closely they adhere to tidy data criteria. For the second question, though, we are going to need to turn to R, because we're going to be looking at computing a rate variable for table 2, and then trying to think about which type of table, whether it's table 1 or table 2, we might want to work with in order to do certain types of calculations. So I'm going to flip over to R now. The first thing that we're going to need to do is actually add the tidyverse functions into our library, right? So I'll run that line of code there. And then you should be able to access these individual tables. So table 1, you can see here where it gives us a subset of countries and years with then the cases of tuberculosis and the overall population in that country in that year. So this is a very small subset of the data from the World Health Organization's tuberculosis data set, which is the larger data set that we'll be working with later. But for the moment, we're just looking at a 4x6 subset of that information. In table 1, it is presented in this format where we have cases and population spread across two different columns, right? So arguably, these are not completely tidy data because both of these represent counts, and they really are just two different cases of, or so I should say, two different categories of counts from the same country in the same year. So another way of looking at these data in a longer format would be what is presented in table 2, where you can see that now for Afghanistan in 1999, we have both cases and the population, right? And we see those two different counts represented on different rows rather than being represented in different columns. However, if I want to compute rates, one of these types of data is going to be easier to work with than others, right? And by rate, we mean we want to normalize the number of tuberculosis cases to the overall population of the country. And then we're going to multiply that by 10,000 to get the number of cases per 10,000 people. So in order to do that, we're going to start with table 2, and we're going to think about how to calculate the rate variable, right? In table 1, it's probably relatively straightforward. I would take cases, and I would divide the number of cases, and then divide that by the number in the population. So I would just take my cases column, divided by my population column, multiply that by 10,000, and I will get the incidence rate per 10,000 people. In table 2, it's not so straightforward because now, even though technically this is a tidier format of data, I'm going to have a harder time making this calculation, right? Because I need it to take this value from row 1 and divide it by this value from row number 2. And then I will get a rate, and I multiply that by 10,000. Then I need to take this value here and divide it by this value here, right? And again, then I can get that rate, and I can get the incidence rate per 10,000 people. So dividing by, row 1 by row 2, then row 3 by row 4, row 5 by row 6, that's very difficult in order to do. So what we would probably actually want to do, if this was the data that we had, and we didn't have access to table 1 already, is actually separate these into two different data frames. So in the first case, I'm going to filter this data to select only the rows with cases, and I'm going to call that T2 cases. You can see I have a smaller data frame that's 6 observations of 4 variables. And then I will do the same thing to select the population. And you can see that I then select only this, the rows where type equals population. And I'm left with a smaller data frame called T2 population, which is also 6 observations of 4 variables, right? Because obviously these should be the same length because they're coming from the same underlying data set. And we are just basically taking what used to be in separate rows, pulling them apart, and then stitching them together into different columns. So at the moment, they're in 2 different data sets, but what I really want to do is merge those together into their own data set. So I can do that by creating something called T2 cases per capita, which is going to be a tibble, so I'll use the tibble function, and that will join together a variable we're going to call year, and I'm going to just pull T2, the years variable from T2 cases. A variable called country, I'll pull together the country variable from T2 cases. I'm going to pull out whether it is a case, right? So I'm going to have a case column, which is going to be the cases column from the T2 cases data set. And I'm going to make a population column, right, which is the population column from the T2 population data set. Okay, so these are really the 2 critical lines of code. I'm taking the cases column from one data set, and I'm taking the population column from the other, and then I'm going to put them together into my new data set. And then once I have those 2 columns now lined up side by side, I can use mutate to actually calculate the cases per capita as the number of cases divided by the total number in the population multiplied by 10,000. And then for the sake of cleanliness, we're going to select only those variables we really need or want to see in order to put that into the T2 cases per capita. So if we run that code, now I have my cases per capita, and if I look at that actual data frame, I can print it to the screen. And you can see that I now have the incidence rate per 10,000 people in each of those countries. Okay, so this then gives me the information that I want, right? But if I only had the data as it was in table 2 to start with, I now have the incidence rate per 10,000 cases. The additional thing, though, that Wickham asks us to do in the book is put these values back into the table, where they belong. So the idea is now we have a different kind of count variable here, right? Let's say that we have the cases, the population, and now we have the rate as a third type of variable that we have for each country in a given year. So we want to fold that back into the original data set that we had in table 2. So to do that, we can take our T2 cases per capita, and we're going to start with the data frame as it is. We're going to use a pipe to push it through the mutate function to create a new variable called cases per capita. And then we're going to rename that as count, where the count values are equal to the cases per capita from our original data frame. So if I do that, we'll want to take a look at this again, and I can say T2 underscore cases per capita. You can see that now I have a variable which is called type, and every instance of that variable is called cases per capita. And the reason for doing this is that the original variable, if we go back to table 2, we had a type variable that included cases and population. So in order to stitch these things back together and fold the rate into a third class of variable here, or a third type of variable here, what we are going to need to do is create a variable that is similarly named type, but now rather than being cases or population, our third type is going to be cases per capita. Once I have that, I can take my cases per capita and I can bind it by rows to table 2. So essentially, I'm taking this T2 cases per capita and I'm appending it to the very end of table 2. I am binding those 2 data frames together as if I was copying one and pasting it right below the other one in a spreadsheet. Right? So that's what the bind rows function allows us to do. Then I'm going to push that result through a pipe and I'm going to arrange the data so that it's sorted by country, year, type, and then count. And if I do that, I'm going to end up with something very different. T2 underscore cases per capita. You can see now I have for each country in each year 3 different types of counts. I have the cases per capita, and I have the population, right? And then I have the same country in the next year. I have the cases per capita, and the population. So this is one way of working with these data in order to kind of take them apart and stitch them back together. So I've folded them back into the original data frame. Obviously, this is going to be a lot easier if our data looked like they did in T1 to begin with, right? Because like we said, if we just have what we see in table 1, right, I already have cases and population as columns in the same data set. So if I want to calculate the rate now, all I need to do is push table 1 through a pipe into the mutate function to calculate a new variable called cases per capita, where I divide the cases column by the population column and multiply the result by 10,000. If I do that, you can see that I get a new column called cases per capita, which is fine if that's what we're going for, right? But we need to learn how to move between different types of representations, because sometimes we might want data in long format, sometimes we might want data in wide format, and the more we can actually move between one type of calculation or the other, or I should say one type of format or the other, the better off we're going to be. Because for instance, sometimes it might be easier to store my data or get a computer to work with my data in completely long format. For instance, if I want to plot these things in ggplot, it's generally going to be better if I have the types arranged as in long format. If I want to, like, for instance, make a category based on which type it is. However, if I want to plot something like a scatter plot or calculate a correlation, I'll probably want those types in different columns, because I want to be able to say, put this column on the x-axis and this column on the y-axis. Right, so depending on exactly what I want to do with the data, we're going to want our data in different formats, and we need to be pretty facile at moving between the different types of formats. And the Tidyverse library includes a lot of really useful functions that allow us to do that. So next in the homework assignment, we want you to recreate the plot showing the change in cases over time, right, which is being presented in the textbook. So in the textbook, the data underlying that uses table 1. However, in your homework assignment, we want you to do it using table 2 instead of table 1. So when we're working with table 2, we're going to need to filter our data before creating the plot. And I'm going to ask you to insert your code and then the successfully recreated plot below. So in R then, what we want to do is create a plot that looks exactly like what they have in the textbook, where they're plotting the number of cases for each country as a function of year. So in order to do that, I will need to filter my table 2, right? And just as a reminder, this is what table 2 looks like, right? I have case rows and population rows for each country in each year. To recreate the figure from the book, I don't need the population data. So the first thing that I'm going to do is push table 2 through a pipe into the filter function and select only the cases. You could also do the same thing by excluding the population rows, but we'll select the case rows here instead. From there, I can use ggplot to set the general aesthetics, where I want year on the x-axis and count on the y-axis. And then I can set a number of other features from the plot. I have the code here, which is also in the script file, which is posted on the class box folder. But if you run that code, you should end up with a plot that looks something like this. Feel free to make your labels a bit nicer looking than mine, right? I'm just running off of the defaults here. But this effectively recreates the plot from the textbook using table 2 instead of table 1. So whatever coding solution you came up with, I would like you to put that into the lab assignment and also put your image into the lab assignment in order to complete that question.